Welcome to Mr. Psycho! Today we're going on a journey to uncover one of science's hidden wonders, the Hall effect. It's a phenomenon that might seem invisible to our senses, but it shapes so much of the technology and science we rely on every day. So, get ready as we dive into a story of discovery, mystery, and a force that began with one quiet experiment and ripples through time, influencing the world of quantum physics and beyond. Imagine a young scientist named Edwin Hall, standing in his dimly lit laboratory in 1879. He's in the process of conducting an experiment that could change everything, though he doesn't realize it yet. Before him lies a thin strip of metal, through which an electric current flows. To anyone watching, it's an ordinary setup, a thin silver strip with electrons calmly moving from one end to the other. But Hall decides to try something different. He brings a magnetic field close to the strip, crossing the electric current at a right angle. At that very moment, something incredible happens. The flow of electrons shifts, and they all seem to gather along one side of the metal. It's as if a hidden force is pushing them to the edge, leaving a charge imbalance and generating what Hall would come to call the Hall voltage. For Edwin Hall, this discovery was a revelation. He'd stumbled upon a way to make the invisible visible. This small voltage became the key to understanding magnetic fields in a way that had never been possible before. And this was just the beginning. Hall's experiment unlocked a world of applications that would quietly transform modern technology, even though he couldn't have known it then. Fast forward to today, and the Hall effect is embedded in almost every aspect of our lives, even if we can't see it. Imagine getting into your car, pressing the brakes, and knowing that Hall effect sensors are watching the speed of each wheel, silently preventing skids or loss of control. These sensors are like the eyes of the car, measuring each movement with precision and sending that data to the car's central system. They monitor the positions of the camshaft and crankshaft, ensuring each part of the engine fires exactly when it should, keeping everything running smoothly. It's a little like having an invisible conductor guiding a symphony of metal, gears, and combustion. Hall effect sensors are everywhere in our digital devices too. They help control the speed of cooling fans, ensuring that computers don't overheat. They sit inside hard drives where they precisely track the position of read-write heads to keep data storage accurate and safe. These sensors are crucial to keeping our devices running without us even realizing it. Hall's discovery, once a tiny voltage on a thin metal strip, now powers entire industries, invisibly guiding the technologies that keep our lives running smoothly. In recent decades, scientists discovered that when you place a material in a strong magnetic field and drop the temperature close to absolute zero, the Hall effect behaves in a completely new way. The electrons, instead of moving freely, start to follow specific paths. They move in quantized steps, traveling only along the edges of the material in a way that defies classical physics. This is known as the quantum Hall effect. The electrons now act like tiny particles following invisible tracks, almost as if they're aware of their paths. This discovery opened up a doorway into the world of quantum physics, and it's here where the Hall effect becomes even more than a sensor or a tool. The quantum Hall effect has given us insights that might one day make quantum computing a reality, leading to machines capable of solving problems we once thought impossible. Imagine a future where calculations that would take years are completed in an instant, where medical mysteries are solved with the push of a button, and where the secrets of the universe can be unraveled. It's a world where the rules of physics are completely reimagined, and all of it started with a thin strip of metal and a magnetic field. The Hall effect, both in its classic and quantum forms, has become a bridge between the ordinary and the extraordinary. It's a silent guiding force, revealing the invisible powers that control the flow of electricity, the inner workings of machines, and even the strange laws of quantum mechanics. From the anti-lock brakes in our cars to the cooling systems in our phones, from the data in our computers to the mysteries of the quantum world, the Hall effect is everywhere, silently shaping the technology around us and opening doors to the future. So next time you step into a car, use a computer, or hear about the latest breakthrough in physics, remember Edwin Hall and his quiet experiment. What started as a simple investigation into electricity and magnetism has rippled through time, changing our lives in countless ways and unlocking the secrets of the universe one discovery at a time. Thanks for watching, and don't forget to subscribe to Mr. Psycho as we explore the mysteries and marvels of science and the universe. If you enjoyed this journey, hit that like button, subscribe, and stay tuned for more tales of the unseen forces that shape our world.